we're going to be working linear systems in two variables. I'm on my website here. We're gonna go through here and select a problem, and I think we'll do this one right here. The link to this website is on my YouTube channel. On the right hand side you'll see intermediate algebra. Okay, so we've gone to the whiteboard. So I've got my system written out right here, and what we're going to want to do is we're going to want to solve for x and solve for y. Well, look here, x is equal to 7, so that was given to us, so that's nice. So now we want to take this 7 and go up to this equation here, plug it in for x, so we have 7 plus y is equal to 12, and then we just solve this linear equation and solve for y. So this becomes y is equal to, bring this 7 over to the other side makes it minus 7, and so we have y is equal to 5. Alright. So that we can check our work by taking both of our x's and our y's here and plugging them in, right? So 5 plus 7 is 12. Right? So we can always check our work. We can also write this as an ordered pair, 7y or 7 5, considering this is our x and this is our y. And let's look at a graph of graphing both of these equations here. Okay, so the vertical line here is going to be the x is equal to 5, and then this is the this line here represents the that first equation. I believe it was at the top there. But we solved for y in that problem, and we got y is equal to negative x plus 12 in order to graph this. Well, do you see where the two graphs intersect? Alright, this is the point that's in common with both of these lines right here, and that's what we're looking for. We're looking for this point of intersection, which as you can barely see here, at 5 we go 5 and then go straight up, and it looks like it's 7 units on the y-axis here. So 5 7 was our solution. Let's do another one. Okay, so let's scroll through and see if we can get something different. There's a particular one here I'm looking for actually. Okay, let's do this one here. Alright, so we had y was equal to 8 was one of our equations, and then our second equation is 8x plus 5y is equal to 88. Alright, so what I'm going to do is I'm going to take, since they already give us y, right, I'm going to go ahead and plug that in. That was nice of them to give us that. And now we have another linear equation. We just solve for x in this problem. So we end up with 88, bringing this over, this would be minus 40. And we have 8x. And so we have 88 minus 40. What's that going to be? Looks like 48. And then we want to multiply both sides by 1 over 8. So we can get a coefficient of 1 here in front of this x. And of course that's going to end up being 6. So now that we have both our x and our y, right? So x is equal to 6 and y is equal to 8, which they already give us. We could write this as an ordered pair, 6, this being my x and this being my y, and this would represent a point in the Cartesian plane, which we're going to go ahead and graph this out now. Alright, so the solution was 6, 8. Here's 4, 5, 6. We go up, and we're going to have to move this screen here so we can see it. Okay, so this is going to be the point right here, 6, 8. Right, that's going to be the point 6, 8. So there you go. So it helps out to be able to geometrically see what we're doing here. You know, when we're solving these systems of equations. Alright, so I'm going to work some more, several more.